Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to do today a quick understanding of a process called Voltaic cells. Now, Voltaic cells are going to give us an idea of how we are going to produce electricity. Remember the oxidation reduction process we've been talking about, half reaction. Produce electricity, produces electrons. And the movement of those electrons produces electricity. Definition of electrochemical energy is energy associated with the movement of electrons, or electromagnetism rather. So as a result, we're looking at the process by which this takes place, and that takes place in voltaic cells. Voltaic cells are defined as electrochemical cells that produce electric current. So they're actually going to generate electrons. And when those become charged, because of opposites attract and like repel, we're going to get movement, and that movement produces electricity, and that's how we can generate in that way. Now, there's specific parts to a voltaic cell. First, we have the anode. That's a place where the oxidation takes place, and it is negative in charge. Next, we have the cathode, place where reduction takes place, and it is positive in charge. Okay, and we have what's called a bridge. It connects between the two cells where ions can travel through a semi-permeable membrane. Now, let me help you out with a few things. I've got a strange brain, but this is the way it works for me. All right, let's look at the word oxidation. Consonant vowels. Remember the A, E, I, O, U, and sometimes Y. Those are our vowels. Oxidation starts with a vowel. Anode starts with a vowel. There we go. So that's an association for you. Likewise, reduction, gaining electrons, starts with a consonant, so does cathode. And now how to associate the charges? Well, you got a little plus here. Plus here is a positive, and that's when that's positive. And then anode, negative is in the anode, negatively charged. Maybe they can help you memorize them. And what's going on here is as we're gaining electrons, the substance is becoming positive because we're actually depleting out material. And as we're losing electrons, those electrons are building up on the side of the electrode. And what is an electrode? Electrode part of the cell, either a cathode or anode, where reactions take place. All right, now, the best example of a voltaic cell, we refer to these as wet cells, would be a car battery. The liquid inside of there, that is the bridge, is sulfuric acid, okay, and it connects between the two cells. Used to be when you had old wet cells, you had old car batteries, you had to actually add water on a constant basis or else they would stop working because of connection. Now they're self-regulating, you don't have to worry about that anymore. So those are the parts of voltaic cells. Let's take a look at an image of a voltaic cell. Over here we have the anode. In the example I have here, we're using zinc as the electrode. And we're going to actually, this is going to get worn away. As the zinc is going to ion, it's going to react out, and the walls are going to get smaller, and that's what eventually kills a battery when those electrodes get so depleted that they can't complete the circuit anymore. The ions then go through this way, across the salt bridge, and those charges build up to the point where they react up. This side becomes positive. Opposites attract, the electrons are pulled, so the electrons move in this direction. The current, which we're going to look at next, is something electromotive force, or EMF, is going to actually go in the opposite direction. And then here we have the reactions taking place. So the zinc is going to zinc ion and 2 electrons, so these electrons are going to build up on top of here. This is going to be negative. It's going to push the electrons the opposite way. This over here is where the copper that we're going to use for this electron, for the cathode, is going to begin to plate out. So it's actually going to get bigger, and the electrons are going to take it away. So this side becomes positive, and it's going to pull the electrons. All right, now, that's all we have actually for new information. If you want to, you can do your turn. Now, I did this in class for a lot of years. I had a student teacher who came out and she did arts and crafts, and I thought, oh, this is silly. But I found, any good teacher, in my estimation, is a human leech, sucking ideas wherever we can. I found that it actually helped the kids see it better by making it for themselves. So basically using this diagram as a basis of it. I've had kids use cups. I've had kids use clay. I've had kids use just draw it, however you want to do it. Now there's a way that I scored this out, so you can just know. Okay, so there are 1, 2, 3, 4, 5 parameters here set up that the cathode and actually there are 6. They're present and correctly identified. The structure, all components of the wet cell are labeled and presented. The direction of the charge, which way the electrons are moving, and which way the current is going is labeled inside there. That it's colorful, that it's original, and that it was presented on time. So that's the way that I graded it, and that was 5, 10, 15, 20, 25, 30 points. Again, this is just for you if you want to. All right, that's all I have. Hopefully not too bad. Take care. God bless.